Hi everyone, on this video we're going to be factoring by special products. So I'll explain that to you as we go. One of the special products would be a perfect square trinomial. So if we have certain things happening in our trinomial, it is a perfect square trinomial. And so basically you can check this to see is this a perfect square trinomial? Now, first of all, you have to notice that the first term is something squared, and so is the last term. So those are perfect squares. And then the middle term is 2 times the a and the b, or negative 2 times the a and the b. Now, you saw these same formulas back when we were multiplying using special products, and now we're going to be going the opposite direction with them. And so if you look at them, you're really just determining, is this really a perfect square trinomial? And if so, I can factor it this way. Notice on the first one, my a would be the x, right? And b would be 5. So then my middle term would have to be 2 times a times b. And the middle term is 10x. 2 times x times 5 is 10x. And so that means that this factors as x plus 5 quantity squared. So you really just have to check a couple of things and then you can see that it factors. And because it is a perfect square trinomial, once you've determined that, that's really what you're checking. On this next one, my a would be 3x. So that would be 3x squared. B would be 2. Because 2 squared is 4. And then it's negative 2 times a times b. Notice the last term is always positive also. That's another part of this that has to be a positive there. All right, so let's look at this. We already know that 3x squared is 9x squared and 2 squared is 4. So the middle term, negative 2 times 3x is negative 6x. Negative 6x times 2 is negative 12x. This is a perfect square trinomial, so it factors as 3x minus 2 quantity squared. Now, it's a minus because right there is a minus, right? So if my second term's negative, then it will factor with a minus sign, or the second term's a negative in that. You can always go back and multiply this out to double check, but if you've checked it with the formula, then you're going to know that, oh, this does factor this way. All right, so let's check this one using the formula. A would be 2x, B would be 7. Oh yeah, I didn't say this either. If you are not following along with the perfect square trinomials, or you didn't understand it when we were multiplying even, then you can still use the AC method on this, or the grouping method. And it will still work out. The middle term is negative, so that's where we have that negative 2 times a times b. And so we already know the first and last terms work out. So let's look at this. Negative 2 times 2x is negative 4x. Negative 4x times 7 is negative 28x. So you can see that, yes, this is a perfect square trinomial. Therefore, it factors in this way, right? The 2x minus 7 quantity squared. All right, next we have 16x squared is 4x times 4x, right? So my a is 4x, my b is 1, 1 squared is 1, 1 cubed is 1, 1 to the 4th is 1, and so on. This is a positive here, so it'll be a plus 2 times a times b. And so we just double check then, is that for sure 8x in my middle term, and 2 times 4x is 8x times 1 is 8x. So yes, it factors as 4x plus 1 quantity squared. And so that's using the special, right? Special products, and that gives us those perfect square trinomials. Now, it is handy to know how to factor these, and in fact, when we get into Chapter 8, that's at the end of the course, we'll be talking about perfect square trinomials for one of the methods of solving that I'll be teaching you then. So you need to learn this. It might take some practice, but it can be super handy if you understand it. Okay, so these just got a little bit bigger. Now these are the kind that if you had to use the AC method, might be a little messy just because of the big numbers that you would get. It's still doable. Yes, you can still factor it that way. 81x squared, my A would be 9x. My B would be 2. And then let's check, right? So it's going to be negative 2 times A times B. And then we just have to see if that equals our middle term, right? So that's negative 18x times 2, which is negative 36x. So it does factor as 9x minus 2 quantity squared. Now on the next one, my first and last terms are not perfect squares, but we also have a common factor here. So if we should have a common factor, we would take that out. This common factor is 5x, and then we would check, right? What do we have left? So we would have 16x squared minus 24x plus 9. Okay, now we have a perfect square, right? 16x squared and positive 9, and you are always checking that. If my first and last terms are perfect squares, then I check the formula to see if it's a perfect square trinomial. And now it's not always a perfect square trinomial. It just happens to be my examples are, because that's what I'm teaching you, right? Okay, so now let's look at this. So my A, maybe I'll put a bracket here. My A would be a 4x, and my B would be 3, and then minus 2 times A times B. So we end up with, we've got the 5x, and then we're going to check that middle term. So negative 2 times 4x is negative 8x times 3. That is negative 24x. So it will factor as 4x minus 3 quantity squared. We just keep the 5x out in front, and that's good. So that is finished for that one. Let's see what's next. And we have the difference of two squares. Now we also talked about this when we multiplied. And so we're kind of going backward from what we did when we multiplied. This one is a little simpler. Also notice it has to be a difference of two squares, right? So I have like x squared minus 9. Those are both perfect squares. It's two terms and subtraction. And same thing with the 64x squared minus 49. They are both perfect squares, and there are two terms and it's subtraction. So it's important that those, if those are the what you're given in this, then you know that, oh, I can factor it this way. So if we identify the A and B, all right, in this case, x is my A and 3 is my B, then it factors as x minus 3 times x plus 3, or you can write it in the other. Notice this says a plus b times a minus b. It doesn't matter which order we put those in. So I kind of go back and forth with those so you can see it's okay either way. On this next one, my a would be 8x. My b is 7. Right? And so that means it factors as 8x plus 7 times 8x minus 7. And once you catch on to these, then you know they factor pretty easily. Here's the thing, you have to recognize, oh, this is a difference of two squares. Here's how I factor it. Because if you don't recognize it, then you're not really sure what to do with it. All right, let's look at some more of these. So on this one, 4x squared minus 225, it would be 2x squared, because 2x would be my A. You might not recognize this one. You can take the square root of 225 on your calculator. It's going to tell you that it's 15. So it is a perfect square. So this factors as 2x minus 15 times 2x plus 15. And then it's factored, right? Most people like the difference of squares as once they, catch on to it. Okay, so on this next one, there's a couple different ways we could go with this. But what I'm going to do is factor out a negative 2. Okay, because my first term is negative, so I'm going to take out negative 2. That leaves me with 36x squared minus 1. So now I have the difference of squares in the parentheses, right? And the negative 2 is just going to stay. So notice that my a is going to be 6x and my b is 1. So factored form would be negative 2 times 6x plus 1 and 6x minus 1 times. It is still times, right? Because we are factoring, so we're putting it in factored form. All right, so here's our last few examples. This one's a pretty quick lesson. It looks like we might finish this in just one video, which is pretty short. Okay, so 81 and 256 are both perfect squares. Once again, you can always take the square root to check if you're not sure about that. So 81 x to the 4th, this would be 9x squared would be my a. And then my b would be 16. Okay. Now, what happens with this one is we end up getting to factor it some more. So we do have a difference of squares. We have 9x squared minus 16 times 9x squared plus 16. The 9x squared minus 16 actually is the difference of squares again, so we're able to factor it one more time. But 9x squared plus 16 does not factor, right? So we just leave that alone. It doesn't factor because it's a sum of squares, right? So far, we haven't had a sum of squares, right? We've just had a difference on each one of these. On this one, once we factored out the negative 2, it was a difference. Okay, so this one stays, right? We can't factor it, but we can factor 9x squared minus 16 as 3x minus 4 times 3x plus 4, and then times 9x squared plus 16 because that part has to stay. This happens sometimes because, right, the square root of 81 is another perfect square. And the square root of 256 is also a perfect square, so that's why that happens. All right, so on this next one, it's a sum. So we can't factor it, all right? It doesn't factor, it is prime. You can make a note to yourself that the sum of two squares maybe I should say the sum of two squares is prime, right? It does not factor. Okay, 147 and 75, those are not perfect squares, but we do have a common factor here, and that common factor is 3. Okay, so if I take a 3 out, I get 49x squared minus 25. And so now I have the difference of squares, and it factors as 7x plus 5 times 7x minus 5. Right, so the difference of those squares, right? 7x times 7x is 49x squared. 5 times 5 negative 5 is negative 25, and that's factored. Okay, so that's the end of this video. We factor some more when we solve equations on the next section, but this is it for now. Bye.